So I welcome you all for this session nanotechnology introduction class. I hope you have seen this curriculum. So it's about nanotechnology and their introduction sessions and synthesis and characterization and applications and current scenario in the market. So what are the applications for right now? So this is about nanotechnology introduction session one. So is my screen visible to you? Let me tell me. Yes, anyone please reply. Is my screen visible?
Yes, sir.
Yeah, fine, fine, good. So my name is Arun Kumar. I'm from Vizag. I'm a professor. I worked as assistant professor in McHale University in Vijayawada. Right now, I'm doing a research scholar in the National Institute of Technology, Andhra Pradesh. So this is our first session. It's about nanotechnology. Okay. So before going to nanotechnology and introduction session, we have to understand what's the importance of this nanotechnology. Why we are dealing with nanotechnology. Okay. So nanotechnology science and applications and history of nanotechnology and the synthesis, characterization, and unique implications and scientific basis of the implications and scientific applications, specific application. So in this session, we'll talk about history and synthesis. Synthesis means production of synthesis nanomaterials and characterization. So characterization means like techniques we have same, we have tamed. I think you may be familiar with these characterization techniques and how to deal with these nanomaterials and unique implications of nanoscale. So unique implication means because nanomaterials has specific properties. Okay, and scientific basis. So what is the science behind that? Why this material behave those kind of properties and what is the science behind that and a specific application because every material has some purpose. We cannot use some every material for every application. So for some applications we have to take some specific material. So it's based on application oriented, not on we should not take same element like iron for all applications. Okay, it's about specific applications, specific materials. So in this way, we have to do like this in this session. Now, first one, learning objectives. So what is nanomaterial? What is the definition? And explain why nanomaterials are interest and indicate different types of nanomaterials. What are the available different types of nanomaterials? And describe different options available for synthesis of nanomaterials. So how to fabricate those kind of materials and mention challenges. What are the challenges associated with the work of nanomaterials? Okay, these are learning object in this session. So I will just give you a brief introduction and theme of this course. Okay, and then if you have any doubts before going to the session, you can ask at any point of time. Then we'll clear this doubts. Okay, so we have so many materials in nature, but we are dealing with majority with engineering materials. So what do you mean by engineering material? So we have so many materials like we have ceramics, we have steel, we have polymers. Okay, we have anything you can name anything, etc. Something like that. So what do you mean by engineering material? So how can you define engineering material? So anybody can answer this question. What is engineering material? You can answer. You can answer. Just reply to me. So what do you think of an engineering material? Go with this flow. So engineering material, if you want to describe a material as an engineering material, is supposed to have some properties. Okay. So what are the properties? So we have so many properties we have basically like mechanical properties, we have chemical properties, and we have optical properties, we have magnetic properties. Okay, we have electric properties. So there are wide range of properties is there. So if you want to describe a material as an engineering material, it's supposed to have these kind of properties. It's supposed to have either a mechanical, chemical, optical, magnetic, electrical. So in majority things engineering follows under mechanical. Okay. So mechanical means it has some kind of strength, ductility, toughness, and hardness. So with this, we can use this material for structural application. So we have a lot of materials available, but if you want to describe a material as engineering material, it's supposed to have mechanical properties, that means strength, ductility, toughness, hardness, creep, etc. Then only we can say this is an engineering material. Okay. Now we're coming forward to nanomaterials. So if you want to go to nanomaterials, we first understand what are the available materials. So we can classify the engineering materials like we have metals, ceramics, polymers, composites, electronic material, biomaterials, advanced smart materials. So in which there are so many classifications are there. If you want to classify metals, like we have ferrous, non-ferrous. So metals are materials which have iron content. We can say ferrous metals, like we have cast irons, carbon, alloy steels, stainless steels. Similarly, we have non-ferrous like aluminum, brass, bronze, copper, lead, magnesium, nickel, tin. All this comes under non-ferrous. Those materials which don't have iron element. Okay, like ceramics, we have alumina, diamond, magnesium, silicon, carbon, zirconium. So these materials have some special properties because they are brittle in nature compared to materials. Like polymers, we have like thermosettings and thermoplastics we have. Okay. And composites also we have similar combination of metal polymer or ceramic polymer or metal composite, something like that. We can classify them. Okay, carbon fibers, ceramics, matrix, glass fiber, matrix. Electronic, we have silicon, germanium, solid state, lasers, LEDs. And biomaterials, we have so many, we have like proteins, artificial bacterium, biosensors. Like advanced smart materials, we have shape memory alloys, piezoelectric materials, we can use in ultrasonic materials, and magnetostrictive materials and optical fibers, electrochemical fluids, and nanomaterials here. We can have lost, we have nanomaterials is the advanced smart materials. So when we are falling from this to here, there is wide range of materials are available, but now current industry are following nanomaterials because it has a unique properties. Because of the unique properties, we are have wide range of applications. And now we'll see what is that unique property these materials possessing. Okay. So in this session, so we'll talk about aware of early use of nanotechnology. This is a brief history of nano materials and nanoscience, and recognize the modern discovery. So, what is the discoveries from earliest stage to now, modern technology? So, there is one aspect. And third aspect in this session, we'll see what is the extent of research has been done and what is the current scenario in the research. That also we'll look at it. So, it concerns about like applications of nanomaterials in current scenario. So these are three things we'll look at it. So before going to the deep, now we'll talk about impact of size. So because nanomaterials at the scale of, we already know in the first session, 9, 10 power minus 9 meters. Okay. For example, if I take a deer, okay, this is a deer and this is an elephant. Now, so we know this because the size is different. Let's say it has like 1.5 meters, for example. I'm assuming that. And this is also elephant. It's a big way. We know this. Let's say this is having height about a 7 feet tall, something like that, which is much higher than deer. Now, can you think of this if the sizes of the elephant and the size of the deer interchange? That means the size of the deer increased to 7 feet and the size of the elephant comes down to 1.5 meters as the deer has. Okay, just assuming the sizes are different, reverse interchange, then what would be the impact on the size of these two structures? Okay, because I'm giving this analogy, this kind of analogy. Why? Because I'm giving this kind of analogy, we can interpret this kind of analogy with the structure of materials actually. So that is the reason I'm giving this analogy. Okay, now if you think about like this interchange, so the size has been reduced from elephant from 7 feet to 1.5 meters, and this increased to 7 feet tall. Okay. Now, what is the impact? Is there any changes? So, at outwardly, that means as a bulk in nature, we cannot see. Okay, this just increase the size only. So that is the only thing we can know. Only height is a visible thing. Okay, but internally the structure, the buildings blocks of the structure of elephant and deer, we don't know what are the things are happening inside. Okay, so we have to understand the concept behind internal structures. Internal structure. Okay, so is there any problem with the elephant comes down from 7 feet tall to elephant has 1.5 meters? So if we or if our deer has 1.5 meters to 7 feet tall, is there any problem? So we have to understand the basic fundamental problems while talking about nanotechnology, because we are going into the deep level at level of 10 power minus 9 meters. Okay, so what is the any impact on this? So before that, going into, we have to understand scenario. Now in this session, exclusive talk about quantum effects. Okay, quantum effects of nanomaterials and quantum confinements and more surface area, more reactivity. So what are these things? So we'll talk about. It's more like properties of a nanomaterial and why these properties are changing. Now, so learning objects here is the first one, quantum size effect, and second quantum confinement, and in which you will also see uh, surface to volume ratio. What is the effect of surface to volume ratio? So that is also we'll see in this class. Now, so quantum size effect is the first one. Here you can see. So here, first of all, we talk about quantum size. Then we need to understand what is energy. Okay. So the confined electrons have higher energy than those in bulk crystal and depends on dot size. The energy shift is derived by delta E is equal to n square h square divided by 8 m a square. Okay. So in simple terms, I will tell you. So we are talking about confined electrons. Okay. Confined electron means electrons will be not moving. So there is no movement of electrons in energy band. Okay, because of that they'll possess high energy. Okay, suppose I will discuss these things in next slides, but look at this equation. That's first one, n square h square divided by 8m square, where n is equal to principal quantum number, h is equal to Planck constant, effective mass m, and a is the dot radius. So when the size increases, what happens here? The confined electrons have higher energy than those bulk crystals. So these have low energy system, and these are high energy system. Okay. So that energy can be calculated by this equation. You just remember the equation. Now, so before going that, I quantum size effect, right? So what do you mean that? So quantum size effect means, so see, when we have material from let's say 1 centimeters, and then micro level 10 power minus meters, so micro level, and this bulk object, and this micro level object, and this is nano level object, nanoscale. Okay, so when we break the material from bulk to nano level, okay, bulk to nano level, the properties will be changed. The properties will be changed. Properties change changes. So what are those properties? These are electrical properties, optical, thermal, chemical, wettability. So these are the major five properties will change. So out of that, and also one more property like mechanical properties also is there. You will see this one in next class. Mechanical property. Okay. Now in this class we'll see 1 to 5: electrical, optical, thermal, chemical, and wettability. So while we are coming down from bulk material science to nano level science, the properties changing. Why are changing? That's the question. Why? Why these properties are changing? Now we'll see that. And this change, by the way, and these changes we call as quantum size effect. Quantum size effect. Okay. So when we coming from bulk to nano level, the properties will be changed. So this changes in property we call as quantum size effect.